Here's section 1.6, the fundamental identity and reference angles. Here's the Pythagorean identity. Is also referred as the fundamental identity of trigonometry. And it reads, if alpha is any angle or real number, then sine square of alpha plus cosine square of alpha is equal to 1. The next part on this slide is figure 6.1. In trigonometry, we need to know the sign of the trig function given the quadrant in which theta lies. So for instance, if theta is in the second quadrant, we need to know that sine of alpha is positive, cosine of alpha is negative, tangent of alpha is negative, and so forth for all the other quadrants. In class, I'm going to show you how you can come up with the sign of any of the trig functions given the quadrant in which alpha lies, and the trig lies in letting r equaling 1. Let's go to the next slide. This is the definition of reference angle. Follow along. It says if theta is a non-quadrantal angle in standard position, then the reference angle for theta is the positive acute angle theta prime, formed by the terminal side of the positive or negative x-axis. Positive or negative x-axis. So here's this figure. So if you know that you have a theta on the first quadrant, the theta prime, or the reference angle, is this angle formed with the x-axis. And again, the angle has to be acute. So you don't want to refer to this angle formed with the negative side of the x-axis because this angle is not acute. But this one right here, it is. So let me continue. So as an example, if we know that theta is 60 degrees, the reference angle, or theta prime, is also going to be 60 degrees. Second figure, so now if the theta is on the second quadrant, like in this picture here, let's say that we use this example 150 degrees, the reference angle, or the theta prime, is going to be this angle. And you should be able to see or determine that the theta prime is going to be 30 degrees. The acute angle formed here, if this is 150, it has to be 30 because this is forming a straight angle. And let's say that theta lies on the third quadrant. Let's look at this as the example in the angle in quadrant 3, 225. So the angle formed here is going to be the acute angle with the negative side of the x-axis, which is 45. And again, how do we get this? We just take 225 minus 180, and this is my reference angle, or my theta prime. The last one, let's say that the theta lies on the fourth quadrant. So as an example, consider 300. So the theta prime, or the reference angle, will be whatever this angle here, whatever the angle is formed here, which turns out to be 60 degrees. Let's go to the next slide. So here's number 1. It says find sine of alpha given then cosine of alpha is equal to negative 4/5, and alpha is in quadrant 3. All this information is telling the sine of alpha is less than 0, or sine of alpha is negative, and this is coming from figure 6.1. From here, what we're going to do is we're going to be applying the Pythagorean identity, and all I'm going to do is I'm going to substitute cosine of alpha for negative 4/5. This is what we get. We simplify, and I'm going to solve for sine square of alpha. Simplify the right hand side, which is just pre-algebra, and then I don't want sine square of alpha, I just want sine of alpha, so I take the square root of both sides, and I end up with positive and negative, whatever this is, and I keep the negative ratio because sine of alpha has to be negative. From here, there's another way I can do this problem, and I'm going to consider this given information, and I'm going to use the idea of reference angle. I'm not going to use alpha, I'm going to use the reference angle to alpha, and I'm able to draw this right triangle. Notice that the adjacent side to the reference angle is 4, the hypotenuse is 5. With the Pythagorean theorem, I'm able to find that this is 3. And then from here, I just need to find sine of alpha, but this is alpha prime. So sine of alpha prime, according to the picture, is 3/5, but I have to take into account the sine of alpha is negative. That's why we write this as our final solution. Let's go to number 2. Here's 2, says find cosine of alpha, given that sine of alpha is equal to negative 12/13 and cosine is positive. At this point, I can just basically do the problem because they're telling me that cosine of alpha is positive. But just a quick review of figure 6.1. This is telling me that this information is telling me that alpha is in quadrant 4. So from here, I'm going to apply the Pythagorean theorem just like number 1. This is what I get. Same process as number 1. I am going to solve for cosine of alpha. Do a little bit of pre-algebra here. Take the square root of both sides. Simplify this square root, the ratio of the square root of this ratio, and I end up with 5/13. And why do I keep the positive? Because cosine of alpha is positive. Another way that I can do this is by using the idea of reference angle. And so this is my alpha prime. Drawing the right triangle, I'm able to find this side using the Pythagorean theorem. From here, if I want to find cosine of alpha, it's just the adjacent side over the hypotenuse. And why do I keep the positive ratio? Because I know that alpha is in quadrant 4 and cosine is positive. And it was also given to me that cosine was positive. Let's go to number 3. This one's different. It says use reference angles to find the exact value of each expression. So I am going to work with 420, but I am going to consider using the reference angle. And you should be able to see by actually drawing 420 that the reference angle is 60 degrees, or the theta prime is 60 degrees. So from here, you sketch your reference angle. Then bring over the radius of 2. From here, if this is the opposite side to the 30 degrees, so this is a short side. So if this is 2, this is half, and this is radical 3, something you have seen on a previous section. So from here, you know that the x value is 1, the y value is radical 3, the radius is 2. Apply the definition of sine, substitute the y and the r, and we're done with number 3.